Welcome to The Explainer. Today we're jumping right into a really fascinating and frankly absolutely crucial piece of research from August 2024. It's titled Emerging Vulnerabilities in Frontier Models Multi-Turn Jailbreak Attacks, authored by Tom Gibbs and a team of 8 other researchers. Now, if you've been following the rapid rise of large language models, you already know their capabilities are expanding at a totally exceptional rate. Today we're looking at exactly how the absolute cutting-edge systems, our frontier models, are being put to the ultimate test. I mean, they're writing complex code, drafting legal documents, and serving as deeply integrated conversational assistants. But with all that immense, unprecedented power comes an equally immense challenge, and that is security.
Okay, let's dive into this. How exactly do you trick the world's smartest AI? What we're really looking at here is a high-stakes, incredibly fast-paced game of cat and mouse in the world of artificial intelligence security. Every single time developers build a smarter, safer, more robust model, you've got attackers right there on the other side, looking for microscopic cracks in the armor to manipulate the system. It's a constant, ongoing battle between the people building the walls and the people inventing brand new ways to climb right over them.
Part 1. The AI security paradox. Power versus vulnerability.
So the paradox is pretty simple when you think about it. As the absolute most capable AI models improve at this exceptional rate, they simultaneously become increasingly dangerous targets. A flaw in a basic customer service chatbot, that's mostly just annoying. But a flaw in a frontier model powering complex enterprise systems, that is a massive security liability. The more we rely on them, the more valuable they become to break. So the crucial point is making sure we clearly understand what a jailbreak attack actually is before we get into the complex mechanics of these new threats. A jailbreak attack is essentially a method used by attackers to bypass or manipulate a large language model's built-in safety filters and guardrails. Think of it as tricking the AI into ignoring its own strict safety training, so it ends up outputting something it was explicitly designed to restrict, like, say, generating malicious software code. It's basically a clever illusion played on the AI's logic.
Moving to Part 2, single versus multi-turn attacks. The delivery changes everything. You see, attackers are no longer just inventing entirely new malicious requests. They're fundamentally changing how they deliver them to cleverly evade detection by the AI safety systems. Let's compare these two specific formats. On one side, we have the single-turn format. This is your traditional approach, just one immediate, highly complex prompt attempting to brute force its way past the AI's filters all at once. On the other side is the multi-turn format, where the malicious input unfolds gradually over a back-and-forth dynamic conversation with the AI. To put that into perspective, a single-turn attack is like an intruder trying to kick down the front door of a building in broad daylight. A multi-turn attack, that's the same intruder casually chatting with the security guard, gaining their trust over a long, seemingly innocent conversation until the guard willingly just opens the door for them.
Let's move to and see how this builds in practice. How does this friendly chat strategy actually unfold? Well, a multi-turn attack happens in very distinct, calculated steps. Step 1 is simply initiating a multi-turn conversation format. You just start a seemingly harmless, everyday dialogue to get the AI engaged. Step 2 is establishing the structural context over multiple exchanges. So the attacker might set up a complex hypothetical scenario, maybe a fictional role play, or even a logic puzzle. They're carefully laying the groundwork without triggering a single one of the AI's alarms. Then finally comes step 3, delivering the actual jailbreak content. By separating the structural setup from the dangerous payload, the attacker successfully bypasses filters that are really only trained to look for immediate, obvious threats crammed into a single prompt.
Part 3, the guardrail blind spot. Content versus structure. The researchers uncovered a fundamental structural flaw in how modern AI defenses are currently evaluating threats. It's not just about what malicious thing is being asked, it's about exactly how the conversation is framed around that request. Now, what's really interesting about this finding is the exact wording in their report. While equivalent in content, they are not equivalent in jailbreak success. The researchers took the exact same malicious request and tested it on frontier models in both single and multi-turn formats. The astonishing finding here? The core content of the request was identical, but whether the attack succeeded or failed depended purely on how the conversation was structurally delivered. The AI's defenses behaved completely differently based entirely on the delivery mechanism. They were getting totally confused by the conversational back and forth. This creates a massive matrix of vulnerabilities. If an AI safety team focuses their defense strategy entirely on defending against a single-turn structure, that does not guarantee defense against a multi-turn attack. And conversely, defending against a multi-turn structure does not guarantee defense against a single-turn attack. Large language model-based filter guardrails have this huge blind spot because they aren't just evaluating dangerous words in a vacuum. These guardrails get confused trying to understand the whole conversation. Essentially, the AI's internal attention mechanism gets distracted by all the conversational padding, effectively losing the malicious needle in the structural haystack. And that complexity is exactly what attackers are exploiting.
Part 4, Rethinking Frontier Model Defenses, a new blueprint for safety.
Because these vulnerabilities are emerging so rapidly and because they're so deeply tied to conversational structure, safety teams absolutely must adapt. They literally can no longer afford to evaluate security in just one setting. And this brilliantly illustrates the practical solution the team brought to the table. To help developers actually fight back, the researchers introduced a brand new dual-format dataset of Jailbreaks. This dataset features rigorous testing examples in both single and multi-turn formats. By providing this, they've handed the AI security community a critical, highly structured tool to study and patch vulnerabilities across completely different conversational settings. It is exactly what engineers need to build much more resilient, context-aware guardrails going forward.
Which leaves us with a final, really pressing question to consider. As AI models increasingly become our long-term conversational companions, assisting us over hours or even days of ongoing dialogue, are our current guardrails looking in the wrong direction? I mean, if an incredibly smart AI can be completely secured against a single aggressive request, but easily manipulated over a friendly 10-minute chat, the entire paradigm of AI safety has to evolve. It's a fascinating look at the cutting edge of technology and a pretty powerful reminder that as artificial intelligence gets smarter, so do the methods used to break it. Thank you so much for joining this explainer, and remember to always keep questioning how the digital systems around you really work under the surface.